1, 2, 3. Okay, so we have, so let's say we have m equals number of literals and n equals
We said 31 or 34?
clauses. Right? So we'll put, so here we have 4 literals, so we need to make 4 columns. 1, 2, 3, 4.
Just go to like the chapters with the 30s on it, and you'll see like, and you can.
Okay.
This.
Then we do we make, then on this side we make n columns for the number of clauses. So there are 4 clauses. There's 5 literals.
I think you have 5 on the left, 5 columns.
1, 2, 3. Okay, thanks. Thanks, Eddie. Thanks, Pablo. Okay, so these guys over here are going to represent the clauses. Okay, so this is clause 1, 2, 3, and 4. Okay, then you're going to make the rows 1, 2, 3, 4, 5, 6.
Okay, so
So in the top
7.
left, m is the number of literals you have,
Yeah.
and then n is the number of clauses.
Yeah. So 1, 2, 3, 4, 5, 6, 7.
Why did she decide to do a 4x4?
So this
Because
is X.
that's the only way to prove this.
That's
Really?
You know, this is my first example. I was like, how the fuck did you do this, man? I'm like, I don't get this.
Right? Now, here we have, okay, so what you do is this. You put ones on each of these guys. So for each, so this is literal 1, 2, 3, and 4. So for each literal, you put ones, right? So for this one, you put 1 on the x1 x bar. For 2, you put a 1 on the x2 and x2 bar. For 3, you put ones, and 4, you put ones like that. So the 1 should look like this: bang, 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 and bang, right? And then for these guys over here, what you do is you put a 1 if it appears in that clause, right? So here there's a 1 because x1 appears in that first clause, right? Where else does it appear? It appears in clause 4, so there's a 1 there. And then same thing for x1 bar, x2 bar, x3 bar, x4, etc., etc. Right? And then, so you fill out the table. So x1 bar will be in clause 2, and that's it. x2 will be in clause 1, and that's 1 and 2. That's it. x2 bar is in clause 3, and that's it. x3 is in clause 1, and that's it. x3 bar is clause 3 and 4. x4 is in clause 2, and that's it. And x4 bar is in the last clause. Here. Okay, so you fill out the table like that, yeah?
Wait, that F that you created, is that like a general thing, or is it just specific to this problem?
This is just an example, yeah, here's just an example.
Could be anything.
Yeah.
When you do the proof, it's supposed to be some general thing, but here he's just showing us an example to show how the subset, like how the algorithm to convert them would work.
So, like when we do it on the test, like can we use that F, or like do we have to be like more general?
It definitely has to be more
It
general,
can be more general.
not this one.
This
This example
so
depends-
the point of this example is to show, is just to help, is to help you prove a general formula. So if you're solving the problem, try to get an example, and then figure out how you can map that example to a subset sum, and then after that, when you're answering the problem, then formally do it for any generic example, right? Okay.
So why do we? Okay. Go ahead.
If x2 does not exist in the clauses, right? Then
Yeah.
on the first half, you would not have that 1 here, right?
Here?
Yeah, so, yeah, on the left, yeah. So if x2 is not in clauses, Would that be 0?
This one?
So x2 is not in the clauses, right? It's not in F.
On this left side.
Yeah, on the left side.
On the left side, you just put
X2 has to be in F.
It
If
has to be in
X2
there?
wasn't in F, you wouldn't have made a row for X2, right?
Yeah, exactly. So that's what I'm asking. You would not have it.
Yeah, you would not have that
Yeah,
row.
okay.
It's not that you put 0 there, it's the
Yeah.
row itself would not be there.
Yeah. So you have one less row. So, yeah.
Yeah.
Wait, so why do we have 4 quadrants here?
Okay, so basically, so this quadrant, there are 4 quadrants. In this quadrant over here, all you do is this row is the number of literals, m. So this row should be m literals. This guy over here is the number of clauses. So if m is equal to 4, n is equal to 5, then it would go 1, 2, 3, 4, 1, 2, 3, 4, 5.
Okay.
Okay?
Uh-huh.
And here there are, on the top half, there are two m rows. Okay? So for each literal you have to knot it. So
Yeah.
there are 2 m rows. And at the bottom, what you do is there are 2 n rows at the bottom. So what you do is at the bottom, you put a 1 and a 1 for each column. Like that. Okay? And I'll explain why in a minute. Alright, and then the bottom row, what you do is this. Okay? You put 1s on the first left side, 1, 1, 1, 1, and then you put 3s.
Is that the size of the literal, or is it for someone?
These are just this will be our target, right?
But why is that the target? Why is
I'll
it not
explain.
like 4?
I'll explain. So 3,
You better explain.
1. Okay, so our target is 1, 1, 1, 3, 3, 3. Now, what's our goal? Our goal is to find rows, a subset of rows. So we have 2m plus 2n rows, right? So the number of rows is equal to 2m plus 2n. We want to find a subset of rows such that every column sums to 1, 1, 1, 1, 3, 3, 3, 3. Okay? Why is that the case? So for example, the rows could be this row, this row, this row, this row, any one of these rows, okay? Why is that the case? Well, we want a 1 in this column because it can't be true that you have both an x1 and an x1 not in the same,
Literal.
yeah.
So that's pretty obvious, I guess.
Yeah, exactly. You can't have x1 and x1 not to be true. So that's why we're constricting these columns to 1. Because you can't have both an x1 and an x1 not to be true.
Yeah.
Okay?
Mm-hmm.
These guys are 3 because we need to have at least, for each clause, so these are the clauses, right?
Yeah.
For each clause, you need to have at least one guy that's true. Right?
Yeah.
So so basically what will happen is the rows that we pick are the satisfying assignment
So is it 3 because there's at most 3 literals
in a clause.
in a
Yes.
clause? It can be more than 3.
It can't be more than 3. But the reason why it's actually 3, yeah, exactly. So the reason why is this. You need to have at least one of these guys to be true, right? So the rows you pick up here are going to be your satisfying assignment. So let's say I pick this row, this row, this row, this row, and this row. That means that in their satisfying assignment, x1 will be true, x2 will be true, x3 will be true, and x4 bar will be true. That's the rows we pick are the satisfying assignments, right? And then what we're going to do is we're going to check the columns down this table. Now we want a sum of 3. The reason why is that if we pick the row, right? The row that we pick will have we need at least 1, 1, right? One of them to be true for each clause. And we get 3 because we have 2 dummy 1s for each clause, right? So basically, in a given column, the column will at least sum up to 2 because by default there's going to be 2 of them, right? Now, if there's no third one, then the sum will be 2, which doesn't equal to 3, right?
Does that mean we want it to be at least 3?
At least 3.
So it can be 4, 5,
No.
6.
No. This needs to be 3 at the bottom, okay? Because in the end, what we're going to do is
Yeah,
from
yeah, yeah.
the first
Yes,
2 m rows, we're gonna pick a subset, all right? Because we have the 2 dummy ones, right? That means that we can because we have the two down ones in the last two n rows, that means we can only pick one row from the first two n rows
Yeah, exactly.
to be as a part of your subset, so that that subset would have a sum of 3.
Okay.
Do you get it?
You guys get that?
So which one would you pick? So to test it, to satisfy that we need to pick.
That's you need to figure out that's the subset problem. So you need to find a subset of rows such that when you add the rows together, you're gonna get your target there.
Well, so our target is 3 in this case right now.
No,
okay.
our target is 1 1 1 3 3 3.
Okay.
1
yeah,
1
yeah.
1 1 3 3 3 3. You guys get that?
You guys,
But how does
get that? Are you guys dead right now?
Yeah.
I think we're gonna get. I think we're gonna get it fully when we finish it. If, as he says, like in the end, we're gonna see it. Just see
This is
in
the
the end.
end.
Do you get it? Do you fucking get it? How the fuck that happened?
Okay, you know what, let's do it this way, okay?
No, but even
Just that three part. We didn't just get
Okay,
it.
how does it show that 3
Go
seconds?
get a Coke.
is-
You always
is-
know where
is
vending
subset
machines
of-
are.
Okay, do we
I-
need a
I
break?
always
Okay,
see
wait,
you
first of all,
come.
we need a break, because I don't want to continue, you guys
I
are
want
just
a
dead. Okay, we'll take a break.
hacks fall.
Wait, break of what?
Bro,
The
you're
lecture
not
is
even
over, right?
studying, Alan is-
Yo, the lecture is over, right?
No.
Okay, do you guys need a break?
No, I
Because
don't.
I don't
break.
want, no, because I don't, you guys look dead, and you guys are.
No, I'm just trying to think. I'll see the
Can you,
lecture.
can you
notes.
yell retarded?
Yeah, it's just B.
So what is left?
Okay, hold up.
Wait, so
Hold up.
you know the set?
You just have this proof,
Yeah.
right?
This
That's
example,
the problem.
this example,
No, for the next
all
one.
your understanding.
Yeah, he's also gonna
The
pass
reason
this
why I
problem
took
to
these off
the
is like, I first
Sure, when
example I
someone
listened
like
to
this
class
one.
with this one. They fucking use
That's
what I'm trying to say. is
The
like-
content wall is the last.
Yeah.
Yeah.
Yeah,
That's
you're
the
sure
actual sum that we're
biceps,
trying to
man.
find, right?
Yeah.
Biceps are
So
sort of
doesn't that mean that
I have like a
it's
bulge on my
a
back.
subset we're able to like.
Yeah, like,
It is the- it is the one.
No, you need the column to sum up to one.
Show it. Only thing you do.
So you need to pick a subset of rows
I worked there.
such that the bottom, such
If I
that you
work
pick a
out,
subset of rows such that if you add up the column of that subset,
There's a lie
it adds the
selection.
number at the bottom. So let's say you select the first
There's
row,
a lie,
the
son.
third row, and the fifth row.
How does we have?
And the seventh
4,
row.
5,
Then
6,
you'll
7.
see all four would sum up to one because like if you take that first column on the left, there's just one number.
Yes,
right?
yeah,
So
attack
that's-
himself
the
in.
rest would be empty. So that would be
This is
one.
like in binary, right?
If you want to
Yeah,
see
yeah.
a
You
really
have to
skinny
specify that
fuck,
like the any number
this
would be,
guy, sorry,
written in binary.
this kid is a real kid.
Yeah, I don't know, some shit about
Dude,
I don't
he
know how
weighs
to
like
put-
200 pounds. That's 7'9", bro.
Who?
Robert
You the tallest man? Shit, you almost had it. You almost had it.
Kimchi Kawaii? What the fuck?
Cute kimchi. Is that right?
Yeah, he said kimchi.
I think it auto-corrected, bro.
Yeah.
Yo, Charlie, do you have kimchi fries?
Huh? Did I ever have it? No.
Oh. Wow, you Korean, you never had it?
This is actually a
Dude,
It
guy.
actually sounds.
When you said that Bao had
It's like
kimchi
Herat.
fries,
So yeah, when the
can't do
first
that
time that
kimchi.
we went to Bao, well,
I
like,
thought you
we
meant
ordered
Bao
Bao.
Chan.
Not about Chan. The Bao place,
What's that?
I think he
meters?
ordered, not ordered
2 meters?
kimchi fries. And it looked so good, but it had pork in it.
That's insane. Man. He's gonna
Bro,
get
we
us
still need
back,
to
bro.
like practice for
We need to practice. There's 5 problems assigned.
At 13 years.
One of them is
he's
just showing the
7'4".
knapsack problem, so.
Yo, for 384, what is it?
See, look what I searched really tall white kids.
The
basketball
assignment 4.
skinny.
Google search over here.
Quiz on assignment 4.
7-4?